With all the buzz about artificial intelligence, it getting smarter every single day, it really makes you wonder, how does our own brain, the OG intelligence, actually stack up against these new machines? The answer? Well, it's probably not what you think. Let's dive in.
I mean, you've seen what tools like ChatGPT can do, right? They can write poetry, they can write code, they can ace exams. It sure feels like AI is catching up, and catching up fast. But is it really the same kind of intelligence? Or is there something fundamentally different happening inside our skulls?
Before we even get to the AI, let's just take a moment to appreciate the reigning champion, the human brain. It weighs just 1.5 kilograms, about 3 pounds, but it's without a doubt the most complex and efficient thing we know of in the entire universe. And as we're about to see, it is a long, long way from being obsolete. Okay, so to understand the competition, we first have to look at where AI got its big ideas. And it turns out modern AI, the stuff that's changing our world, is directly inspired by the architecture of our very own brains. You see, your brain isn't static. It learns by literally rewiring itself. Every time you learn something new, the connections, the synapses, between some of your 86 billion neurons get stronger, and others get weaker. This amazing ability is called neuroplasticity, and that is the core idea that AI developers totally borrowed. And here's how AI actually puts that idea to work. So these deep learning networks, the kind that AIs use for vision, they build up understanding in layers. It's kind of like building with Legos. The first layer sees just simple lines and edges. The next layer combines those into parts, like a wheel or a door. And then the final layer puts it all together to recognize, hey, that's a car. It's a surprisingly good imitation of how our own visual cortex works. Now, this leads to a discovery that is just wild. Researchers have found that as they make AI language models better and better, their internal activity starts to look more and more like fMRI brain scans of humans processing the exact same information. It's like engineers and millions of years of evolution are somehow arriving at similar solutions. But that's only part of the story. Because this right here is where the two paths split, and they split dramatically. For all the similarities in how they process information, AI and the human brain have profoundly different starting points. An artificial neural network begins its life as a total blank slate. It knows absolutely nothing. Zero. It has to be fed colossal amounts of data. We're talking the equivalent of the entire internet just to learn what a cat is or how to string a sentence together. A baby, on the other hand, the complete opposite. A baby's brain does not start from scratch. It arrives preloaded, with the results of millions of years of evolutionary software development. It is incredibly structured from day one. And this isn't just a theory. There are these brilliant experiments where scientists show babies an impossible outcome. So they show them 5 objects, then they add 5 more. And the result is still 5. And what happens? The babies literally stare longer. They're visibly shocked. And why? Because they already have an intuitive grasp that the math is wrong. And it's not just numbers. A newborn's brain comes equipped with this incredible starting toolkit. We're talking a sense of probability, specialized brain circuits just waiting to soak up language, and a fundamental understanding of space. Babies are not passive little sponges. They are active, brilliant learners from the moment they're born. Now, all this innate structure gives humans another superpower. And it's something that current AI really, really struggles with. It's the ability to think in symbols and abstract rules. It's like we have a language of thought that goes way beyond just recognizing patterns in data. All right, time for a quick test. Find the shape here that doesn't belong. Oh, wait.
All right, time for a quick test. Find the shape here that doesn't belong. I'll wait. Just kidding. I bet you found it instantly.
That was super easy, right? And that's because your brain didn't just compare a bunch of pixels. It immediately used this abstract symbolic language of geometry. It recognized the idea of a square, 4 equal sides, 4 right angles, and instantly saw that one shape broke the rules.
Okay, round 2. Now, try to find the intruder here. A lot harder, isn't it? The weird thing is, the intruder has been changed by the exact same amount as before. But without those simple geometric rules to guide you, your brain's superpower can't help. You're forced to do what a computer does. Just compare them pixel by agonizing pixel.
And this really reveals the fundamental difference. We humans are amazing when there are abstract rules to lean on. But baboons, and get this, early versions of visual AIs, they are totally insensitive to them. They do just as poorly on the easy test as they do on the hard one, because for them, it's all just comparing raw pixels. They don't get the idea of a square.
So this brings us to our final section, where we can see how this lack of true symbolic understanding causes even the most advanced, cutting-edge AIs to fail in some truly spectacular and surprising ways.
So a researcher gave a top-of-the-line AI a simple geometry question any high school kid could figure out. This was the result. And, it's just completely wrong. What's so mind-bending is that the AI could generate the computer code to draw this image, but it couldn't see that the image it drew didn't actually fulfill the request. All right, check out this last example. You probably recognize the famous Mueller-Lyer illusion, but I want you to look really closely at this specific version. The top line is very, very clearly longer than the bottom one. Got it? Okay. And here's the AI's response. It correctly identifies it. This is the famous Mueller-Lyer illusion, and then it confidently says, the lines are actually the same length, which is just wrong. So what on earth is going on here? Here's the kicker. The AI isn't actually seeing the image in front of it. It has just learned from all the text on the internet that when a pattern that looks like this shows up, the correct text to spit back out is, the lines are the same length. It has a perfect description, perfect linguistic competence, but zero genuine comprehension. It is talking, not seeing. So let's just pull this all together and look at the scorecard. The human brain learns from tiny amounts of data because it has this incredible head start from evolution. It's a master of symbolic logic. And it does all this on about 20 watts of power. That's enough to run a dim light bulb. Meanwhile, current AI needs massive data sets, starts from scratch, is really weak with abstract rules, and consumes megawatts of power in giant data centers. And this all leads us to the fundamental question about the future. The real difference isn't just processing power. It's about having an internal model of the world. So as these AI systems get more powerful, are we actually building something that will one day learn to truly think and reason and understand? Or are we just building a more and more convincing parrot, one that just gets better and better at talking without ever truly knowing what it's saying?